Hello again. In this lecture, we're going to quickly go over standard data structures with lists and arrays as an example versus node-based data structures, such as linked lists. We're explaining this because something that you always want to consider for your program is whether or not to use a standard or node-based data structure. There are distinct advantages and disadvantages to both, and I'll point some of them out right now, starting with lists. The main advantages of lists are ease of traversing and direct access, which means that if you know the index of an item, you can directly get to it. So taking this small example in here, this small list that we have in here, you can see that it is a normal list. As a list in Python, it contains different types. So we have integers, characters, strings, and even booleans and other lists. If I want to access the number 13 that is in here, I want to go to 0, 1, 2. So the index of 2, direct access. The index of 2 is always going to give me or yield the number 13. This can be very, very helpful and easy, especially if you know what you're looking for. So it makes searching for it much easier. As an example, if we start working with Python here, I'm using the idle shell, which comes standard with Python. So I have the list, my list, which is the one that you just saw. It includes a smaller list L, which is the one in here. It's not that complicated. It's very, very simple. What I want to do in here is check whether I can directly access something, and I can do the following. Print the item in the, let's say the 8th index is, and comma, my list for that 8th index. Close it and run. And you can see the item, the 8th index is true. Now if you go back here and say 0, 1, 2, 3, 4, 5, 6, 7, 8, it is in fact true. If I want to change this to the item in the 3rd location or 3rd index and put number 3 in here, it's going to give me this. That is because 0, 1, 2, 3. This is the 3rd location in my my list. Now that shows that direct access is actually very, very simple. With lists, you can just specify the index and you are there. Let's check the other advantage of lists, which is traversing. Traversing is actually fairly simple with lists and arrays. All I need to do is start a loop. And I'm going to do this with the while loop. That is because the for loops in Python are going to do all the work for me. And I want to show this live. So what I'm going to do is make an index that is equal to 0. Then I'm going to say while this index is less than the length of my list, the one that I created. What I want you to do is print my list for the index for that index, and then of course I need to increase that index. That is because if I don't increase it, I'm going to go into an infinite loop. And again, run this. You're going to see that the item, the 3rd index is this, then we have 1, x13 this, and every single one of them. If I actually do this again in here and say my list, just to check, I'm going to see that it is in fact the same, like 1, x13 this, it is the same as in the list. So traversing is really, really simple. All I needed was, in reality, just the while loop, just this 2, 3. So it's 3 steps. Now, when we think about the disadvantages of lists, in contrast to the advantages, I'm going to see that any type of insertion or removal is going to be hard. Because if I want to insert something, especially if I want to insert something at the beginning, that means I have to shift every single item in that list. And as we have stated earlier in another lecture, if I have a small list, that is not a problem. But the more the size increases, the bigger the problem is going to become. And you're going to lose a lot of precious processing time. So the main advantages of lists are going to be the shifting that normally happens with the insertion and removal of items from the list, which is going to create additional unneeded processing, especially if you're removing or inserting at the beginning of a long list. Now, what about linked lists? Linked lists are actually the exact opposite, which means the advantages of the lists are the disadvantages of the linked lists and vice versa. So if I want to look at insertion and removal, for instance, when it comes to lists, they are hard. They are not hard, but they take more processing time. But when it comes to linked lists, they are really easy. And they are considered actually to be an advantage to it. On the other hand, when we look at traversing, it's going to take a lot of time and a lot of processing just to go from one point to the next. Let's take this example in here. This example shows a traversing. This is 1, 2, 3, 4, 5. It's a 5-node linked list. And I want to go from point A to point B from the beginning to the end. And you can see that in here, it's much complicated. In reality, it's going to be really easy, but comparing it to list, it's more complicated. So I have the head, and we said that the head is always going to point towards the first item or the first node in a linked list. Okay, what we need to do when we want to start from beginning to end is we need to get another pointer, and that pointer is going to be called the current node. So this current node needs to look at the head and point towards the same location that it's pointing towards. Then it needs to look at the next pointer of its location so that it points to it. Then next, next, and next. And you can see this like a current node in here pointing towards the first location, second, third, fourth, and fifth, and finally pointing towards nowhere because it took this pointer, which is pointing towards nowhere, pointing towards none. So you see that is taking a lot of processing for something that was as easy as a while loop. And in reality and programming, it is going to be easy as well, but the mentality of traversing is going to be a little bit different. Now, what about the advantages of a linked list? Adding and removing, and especially inserting and removing, is much, much easier in here. So if I want, let's say I want to insert something at the beginning, and we said that with lists, if I do this, it's going to make the most processing or take the most processing power. That is because I have to shift everything to the right. With linked list, I don't need to do that. It's very, very simple. All I need to do is insert a node in here, my new node, and say, hey, new node, your next pointer should point towards where the head is pointing. So I create this connection in here and then say, hey, head, instead of pointing here, point at the new node. So what we do is just point toward the first node in our current linked list and then make the head point towards the first one. So there is no shifting whatsoever. Even if this linked list was made of millions of nodes, what happens is just 2 pointers and that's it. There is no processing. If I want to insert something in the middle of a linked list, what I need to do is have 2 pointers towards the current node where I'm standing, where I want to insert before, and the predecessor node, which is where I want to insert after, and then do the same thing, saying, hey, the node before me, please point towards me and not this location, point towards me, and I'm going to point towards the current node, and that's it. Even if there's a million nodes to the left, a million nodes to the right, what we just did was insert without any shifting. And the same thing can happen when we insert at the end. We have to traverse our nodes and our linked list until we reach a node that points towards nothing, and say, hey, instead of pointing towards nothing, points towards me. I'm the new node, and I'm going to point towards nothing, so I'm going to mean the end of that linked list. I hope this was clear enough. Starting with the next lecture, we're going to look at the code. Thank you so much for listening, and I'll see you in the next lecture.